In this video, we are going to see ionization constant of water or ionic product of water. So let us see something about water. You know that water is a weak electrolyte. When I say it is a weak electrolyte, means it will dissociate to a very lesser extent. Second very important point is water is a bad conductor of electricity. When this particular water will start conducting, if you put some amount of acid or base, means whether if you acidify water or you add a base to water or any other salt, then only water will conduct electricity. Otherwise, water is a bad conductor. So let us see how water will ionize. Students, here I am using the word ionization. You cannot use the word dissociation here. But as you see that this is a covalent compound, so I'll be using the word ionization only. What is the difference between ionization and dissociation? For that, you refer to my dissociation and ionization difference video. Here, water I have considered, physical state of water, I will write it as liquid. When I add this water to water means what? I am considering water, it will form H plus and OH minus ions. Very interesting to note that this H plus ions, as you know, any ion which is formed will never be naked, because as soon as the ion is formed, then it will be solvated or surrounded by the solvent. So you can write 2 moles of water here, then it will become hydronium, that is H3O plus. So meaning is same whether I write H plus or hydronium ion. In this derivation, I am considering H plus for the derivation. Now, if I see the equation, I will apply now law of mass action. So, applying law of mass action. Now, this I will use as a constant is equal to active mass of H plus, active mass of OH minus upon active mass of water. You know that water is a weak electrolyte. So, the concentration of water will almost remain constant, because it is always taken in excess. So what I will get is K is equal to H plus OH minus ion upon constant. Now can I take this constant to this side? So what I will get is K into constant. So constant into constant, I will get a new constant. So that constant I will write it as K, and as this is for water, I will mention here W is equal to H plus and OH minus ions. So this is the expression for the ionization constant of water. What is Kw, student? This is called ionic product of water. Ionic product of water or ionization constant. And what or how you can define this ionization constant? If you see the sign between the two concentration, this is a dot, means what, student? This is multiplying. Means what you are getting here is the product. Right? So how I can define ionic product of water? It is the product of active masses of what? Hydrogen ion concentrations and hydroxyl ion concentrations at a given temperature. So how I can write the definition? Let us see. So definition we will see now. So this is the definition. On what basis I wrote the definition? Ionic product of water is what, student? It is the product of, this is called as the molar concentration, or you can write active masses. So product of molar concentrations of hydrogen ion and hydroxyl ions at equilibrium for pure water at a given temperature. When I mention temperature here, means Kw is a temperature dependent factor. Right, student? Now let us see what is this Kw value is. Kw is equal to 1 into 10 raised to minus 14 at 25 degrees Celsius. This is a fixed value. So if I consider Kw is equal to H plus OH minus ions, then at 25 degrees Celsius, when I say that Kw is 1 into 10 raised to minus 14, means there is equal contribution of H plus and OH minus ions if water is pure. So what will be the concentration here, student? H plus will be 10 raised to minus 7 mole per dm cube, and OH minus ions concentration will be also 10 raised to minus 7 mole per dm cube. So this concentration remains constant until and unless you add an acid or a base to it. If you add an acid to it, then this concentration will go on increasing while this will go on decreasing. So this is what is related to the other concept. So here if I say that this is at 25 degrees Celsius, means as the temperature will go on increasing, the value of Kw will also increase. Let us take for example, if I say that the value of Kw is equal to 1 into 10 raised to minus 12. So what I can conclude here, that H plus ion concentration and OH minus ion concentration must be equal to 10 raised to minus 6 mole per dm cube, provided water is pure, and the temperature must be higher than 25 degrees Celsius, because it is a temperature dependent factor. Now what do you think will be the unit for Kw? So to know the unit for Kw, I am using the same expression here what I have, that is H plus and OH minus. The unit for this H plus is mole per dm cube, and this will be mole per dm cube. So what is the unit of Kw if I consider at 25 degrees Celsius will be mole square dm cube 6. So this is the unit for Kw at 25 degree Celsius. Thank you, students.